Hi everyone, my name is Dr. David Jacob with Science Education Innovations, and in this video series I'm going to talk about the NGSS or NISLIS in the state of New York, and we're going to talk a little bit about how this video series is set up today. So in this video series, what I'd like to be able to do is talk about both theory and practice. How do we bring those two together in our science classroom? So education is always changing and there's always initiatives based on research. Sometimes the research is better than others. In NGSS, these are definitely based on some really powerful research. Teachers are expected to make these changes and adaptations to their classroom, both in teaching methodology and what they put in front of students. But they're not always understanding why this is the case. So the research behind this, I'm going to try to infuse this as much as I can in this series. So theory and research is one thing that sometimes science teachers surprisingly don't look into. What's behind this in educational research? Not just the research of science, but what's happening in education. And then practice and in real life, this looks very different than it might in other ways. So in episode one, I do a combination of the two of these so that you can kind of see how that comes together. And then in all of the other videos, I'm going to try to probably either choose one or the other. There'll probably be a few mashups of there. But warning, try really hard to endure the theory. And I say endure because people want to push over and go, how do I get to it? How do I actually do it? I don't have enough time. But if you don't understand the why behind it, it becomes a little bit more difficult for us to be able to make those changes in our classroom. So what are some of the shifts for science education that are happening that are really critical? We want students to be critical thinkers in this world, not changing. It's in lots of mission statements and things like that. So how do we do that in science? The science and engineering practices are concrete methodology for students to be able to think critically about the natural and design worlds. So that is what they are doing in your classroom. The cross-cutting concepts are kind of like bigger ideas or thinking tools that we can use to analyze data, to be able to make sense of the world around us. And then the disciplinary core ideas are not just a bumper sticker change, but are really a significant change in how we approach the big ideas of science. So rather than going, into the weeds in some of our content courses, we want to really say what is the core idea and how do we relate the kids back to that core idea. So when we're using these tools to make sense of the world around us, our job is really to prepare students to be. These are the three things that I get out of bed every morning for. And that is to make one, all of our students scientifically literate. How do they know enough about the science world to be able to understand what's happening around them, that they make good decisions for themselves and their family, and that every single American is scientifically literate? Second reason is to create future scientists and engineers. We want students to really be excited about it and not just the content, but the way we do science as well. And third, and probably most important, is our lawmakers. Our lawmakers at the national, at the state, and at our local level all need to be scientifically literate in order to make good decisions for the rest of us. And we want to make sure that they understand science well enough, not just the content, but the core ideas to be able to make this make sense to them. So thanks for watching. This will be a great video series. And in the comments, tell me what you want to hear, and I'll try to address your concerns. Please watch and click subscribe when you get a chance. And thanks very much for your help today.